Okay, welcome to a video from lesson 2, just kind of describing where the formula that we've been using comes from. So just to review the formula, the projection of u onto v, which we often call u sub 1, that is the dot product of u and v divided by the magnitude of v being squared, and then you multiply by vector v. So my goal in this video is just to kind of show you why this formula works. I have the picture that we did in the first example set up here. I kind of have the diagonal lines out of the way. We might look at some of them here in just a little bit. But I want to have a reason for why this black vector, why I get that by doing all of this math right up there. And so if we just go back to the very basics of a vector, it has two things. It has a direction and it has a magnitude. And so we're just going to try to put those two things together to kind of guarantee that this formula should get us whatever this vector is. Okay, so let's start by talking about the magnitude of this vector. Okay, if I were to put in a theta, angle theta right here, the angle between vector u and then vector v, and I thought about just this length in black that I know I have here. This is a right angle right here. Let me put in those perpendicular lines. Okay, this is 90 degrees. That's how we built that. So if this is theta, cosine of this angle should equal the adjacent side, which is this, so u sub 1, over the magnitude of this, which is the magnitude of u. So this fraction is very true right up there, that cosine of theta, if this is the theta right here, equals this fraction. And remember, we want the magnitude of the black vector. Well, that's what this numerator is. So if I were to go and just rearrange that, I get so I just multiplied by the magnitude of u on both sides. So now magnitude of u is right here. Magnitude of u times cosine of theta equals the magnitude of this projection vector of u sub 1. Okay, the other thing we want to look at is the direction, and for that I want to be thinking about a unit vector. So what is the vector that's going in this direction? So in the direction of u sub 1, but it's also in the direction of v, vector v, it will always be that way, but it's going to be a unit vector. And that's one that we've probably been using a little bit more. If I took vector v and divided by its magnitude, I now have a unit vector that goes in that direction. Okay, so before I get into that too much, just think about that again. If I take the vector v, so this is an xy value, and I divide by the magnitude of that vector, I create a unit vector, something that's going in that same direction but is only going a distance of 1 unit. Okay, so now I can put these two things together, the idea that I have magnitude and I have a direction, and now I should be able to describe this vector that we're looking for. I have the magnitude of this vector, I have the direction of this vector. Let's put them together. So the projection of u onto v, which I'm calling u sub 1, I can get that by taking the unit vector, which is the fraction right here, and multiplying it by the magnitude of u sub 1. Right up here, the magnitude of u sub 1 was this stuff, so that's what I put right here, the magnitude. This is telling me the direction, but only going a length of 1. So I put this all together. I've taken this vector that has a magnitude of 1, multiplying it by the magnitude that I want, and I get this stuff. Okay, so right now that's looking nothing like the formula that we originally wrote up here, and that's in our notes. So I want you to go back to a previous topic that we looked at in this unit where we talked about an angle between a vector, and we had a formula that we solved for cosine of theta. So if I take that formula and I apply it to these two vectors that we're talking about here, vector u and vector v, this middle fraction right here is replacing the cosine of theta. It's just coming from that same overall formula that we had before. Oops, I can't do that. This kind of ignore that u there if that's distracting to you. But as I have that here, a couple things are going to work out. First of all, this is in the numerator, and it's just a number. And this is also in the denominator, and that's just a number, so they cancel out. Okay, we like this dot product right there. That's part of the formula that we want. this is a number and that's a number, and if I multiply the same thing together, I can just write it once and square it. So those things will end up in my denominator. And then this part right here, that's just a vector. It's not a number. So everything that I've circled so far or crossed off, those are all numbers, and using algebra ideas we can rewrite them. But this is a vector. That just goes on the back. So we have that number that we used in examples here, that scalar multiplied by vector v. And so you'll notice that the projection vector, the black vector in my picture, is always going in the same direction as the original vector v. That's just a little bit about where that formula came from. Kind of a lot to put together, but feel free to ask some questions.